Welcome back everyone to the last section about graphing trig functions. So far we've talked about the parent graphs, which are absolutely important that you know, and then we talked about transforming sine and cosine. So today we're going to do tangent, cotangent, and then secant, cosecant. I'm only going to do a few examples. I think only one big example of this, so make sure you check out the homework, check out the notes. This is still the same process. List the important points of the graph, do the transformations, and then regraph the important points. The first thing I want to talk about though is just remember, when we talk about the period, most things have a period of 2 pi except for tangent and cotangent. So, if you've ever had a graph like this, and I ask you for the period, the first thing you'd have to do is you'd have to factor out the 3. And then what's the period? Well, the period is usually pi, but now it's being divided by 3. What does this do? Well, this is a phase shift that moves it right 3. So you would draw your tangent graph like you normally would. You would find the important points. So what are the important points of the tangent graph? Well, 0, pi, 2 pi. Those are all x-intercepts. Pi over 2, 3 pi over 2, 5 pi over 2. Those are all asymptotes. It works going backwards too. And what would you do with those important points? You would divide the x values by 3, get your answers, and then you would add pi over 3 to all your x values to move them to the right. Secant and cosecant, because they come from sine and cosine, they have periods of 2 pi. So let's actually just do an example of one here. Let's graph this function. Well, the first thing I'm going to do is rewrite it. If I pull a pi over 2, if I pull a 2 out of a pi over 2, in other words, if I divide this by 2, I'm going to get pi over 4. You can always double check yourself to distribute back in and see if you get what you had. So let's explain what happened here. What's the 1/2? Well, it's a vertical shrink by 1/2. So let's call that a vertical compression, just so I don't get shrink and stretch confused. It is a horizontal compression by 2, because remember this is the opposite of what you think it should be. And then this moves it left and right. In this case, left, pi over 4. So those are the 3 things that I need to do to my cosecant graph. I need to take all of my y values, make them half as tall. All of my x values, make them half as wide, I guess. And then take every single x value and subtract pi over 4 from it. Before I do that, I need to have some idea of what the cosecant graph looks like. I'm not going to draw the cosecant graph first. Remember, I'm going to draw the matching graph, which is sine. So sine of x is 0, 0, pi over 2, comma 1. Let's make this a little bigger. Comma 1. Pi, comma 0, 3 pi over 2, comma negative 1, and then 2 pi. So this is the sine graph. Again, badly drawn. So why am I drawing the sine graph? Because it helps you draw the cosecant graph. Remember that for the cosecant, every place there was an x-intercept, there's now an asymptote. And every place that there was a max, there's now a min. So what are the important things on this graph? Well, on this graph, there's an asymptote at 0, pi, and 2 pi. There's a max at pi over 2, comma 1. There's a min at 3 pi over 2, comma 0. So let's go back and list those points. So at 0, doesn't really matter what you put here, there's an asymptote. In fact, let's just call this x equals 0. And then at the point pi over 2, comma 1, there was a min. And then when x got to pi, there was an asymptote. And then 3 pi over 2, comma negative 1 was a max. And then x equals 2 pi was an asymptote. Now, this graph goes on forever. So why am I only graphing these points? Well, because these are one period. I could graph any points that I wanted to as long as they made a period. I just picked the ones that are easiest. So let's start with transformations. A vertical compression by 1/2. In other words, I'm going to multiply all the y values by 1/2. But think about a vertical asymptote. If I compress it by 1/2, it doesn't change the vertical asymptote. So this stays the same. And this stays the same. And this stays the same. Now this, if I compress the y value vertically by 1/2, in other words, if I multiply by 1/2, I'm going to get pi over 2, comma 1/2 is now a min. And 3 pi over 2, comma negative 1/2 is now a max. So that took care of the vertical compression. Now we have to do the horizontal compression by 1/2 or by 2. So in other words, everything is going to get 1/2 as big, going to compress it 1/2, but the x values. So I'm going to multiply all the x values, not by 2. Remember, do the opposite of what you think you should because it's with x. So if I multiply x equals 0 by 1/2, I still get x equals 0. If I multiply pi by 1/2, I get pi over 2. Now why am I doing this with the asymptotes? Because I'm compressing the x value. 2 pi divided by 2 is just pi. These points, I'm going to take them and I'm going to compress them by 2 or multiply them by 1/2. So pi over 4, comma 1/2 is now the min. And 3 pi over 4, comma negative 1/2 is now the max. So I took my important points and I multiplied the x values all by 1/2. The last one, left pi over 4. That means I'm going to take all of my x values and move them left pi over 4. So I'm going to subtract pi over 4 from all my x values. Well, let's do the asymptotes because they are x's. So if I subtract pi over 4, I'll get a negative pi over 4 as an asymptote. I'll get, that's 2 pi over 4 minus 1 pi over 4 is 1 pi over 4 as an asymptote. That's 4 pi over 4 minus 1 pi over 4 is 3 pi over 4 as an asymptote. So I just subtracted pi over 4 from each of those. Now I've got to subtract pi over 4 from each of these. Pi over 4 minus pi over 4 is 0. The y value doesn't change. Is now my min. 3 pi over 4 divided by, subtract pi over 4 is 2 pi over 4. Or pi over 2, comma, negative 1/2 is my max. So now I took the 5 important points from the original graph, did my 3 transformations, and now I have the 5 important things on my new graph. So let's go do the asymptotes. The asymptotes are negative pi over 4, pi over 4, and 3 pi over 4. So, negative pi over 4, pi over 4, 3 pi over 4. So there's my new asymptotes. The new min will be at 0, comma 1/2, so 0, comma 1/2. So that's the min of that part. And the new max will be at pi over 2, comma negative 1/2. Pi over 2, comma negative 1/2. And there's that. Now why does this graph, which is done, because that's an entire period, why does this graph, the new cosecant, look so much smaller than the rest of them? Because it's been compressed horizontally by a factor of 2, and it's been vertically shrunk by a factor of 1/2. So, again, list out the points that are important. This time I had to draw the sine graph. If you don't need to draw the sine graph, that's fine. If you can jump straight to drawing the cosecant graph in navy blue, that's perfect. Take your 5 things that are important, or however many things are important that you need, make a list of them, and then do the transformations. Take your time on this and you will get it correctly. Try to do it one step at a time. Don't try to do all of it at once.